The Green&Grey wall project involved two French companies, Le Sommer Environnement and Sous les Fraises, and one Belgian company, Biodiversity. The goal of the project is to develop and assess a modular green wall to treat the grey water, and especially for the building refurbishment sector. The idea is to create a multifunctional unit in order to bring vegetation into cities, favor biodiversity, and obviously treat the grey water in order to produce reusable water. The grey water is coming from showers, but also sink from the bathroom, and is less polluted than wastewater, and therefore easy to treat in the green wall. Water can be reused for watering, toilet flushing, or other non-potable use. This green wall and multifunctional wall will make the cost more bearable by the investor and help it to enter the refurbishment sector. However, remaining questions are how to implement it in refurbishment, how to do this modular green wall, but also which plants should be installed, what is the impact of the grey water on the pollinators, and on which building should it be implemented, and what is the impact on terms of thermal balance. Sous les Fraises built a prototype of this module and ended up with a brilliant idea to use the knowledge of the scaffolding sector. Indeed, they already have a large knowledge on how to hang the scaffolding pipes on different types of wall, different types of materials, and with different age of the building. So the idea is to create this structure to hook up on the wall, and to create the panel at the plant, the green wall panel at the plant, in order to have a prefabrication product. The module is composed of this structure from scaffolding pipes, pipings for irrigation and to collect the excess water, a metal frame with a plastic panel in order to have the structure, and finally the membrane where your holes are placed to install the plants. The last element is a gutter in order to collect the excess water. Biodiversity worked on the plant selection in order to encourage native plants, to have plants adapted to humid soil with phytopurifying characteristics to attract pollinators, and also to have some evergreen plants for aesthetic reason. They end up with a 20 plants selection because not only one plant can fulfill all these criteria. And the laboratory EGCE will work on the effect of the grey water on the pollination by comparing two walls, one irrigated by grey water and one irrigated by the tap water. By analyzing the visit of pollinators and the effect on the fruit, we can be able to understand the link between grey water and pollination. The insect will be monitored with this device and to know which pollinator is visiting which wall. The last part of the project was on the thermal balance of the building, and the idea was to select the most suitable building based on the multi-criteria analysis, where the available surface of wall was identified and where the water balance was quantified with the grey water production, the water demand, and the surface needed for the Green&Grey wall. The multi-criteria analysis ended up with 4 different typologies, and one was selected for the rest of the study. The next part was the development of a model in order to consider the evapotranspiration of a green wall. indeed, this phenomena is not really taken into account in most of the software and most of the commercial model available for the energy balance. Even though this phenomena is really important in terms of heat transfer and energy balance. So we developed and adapted a research model in order to be able to understand the effect. We've used it to model the case scenario of Montpellier City in France, and we saw that the vegetated wall allows a drastic decrease of surface temperature up to 7 degrees for the west wall compared to a bare wall without green vegetation. The wall worked also as an insulation during winter and summer, and the last results was to highlight the effect of the evapotranspiration compared to only a shaded wall. And we saw that it's during the warmest hours of the day where the evapotranspiration is the most powerful and allows the largest decrease of the temperature, which is really important with the heat stress that we can have during summer. The next step of the project will be to continue to work on this modeling, and especially to try to understand the effect on the surrounding of the building, and therefore on microclimate modeling. We want really to thank the Meta Building program to have funded this project. We think that this module will be very likely to become a standard for the next project, and all of three will try to promote this technology and implement it in our project.